Okay, lesson 4. So our surface area of cylinders, your practice questions, and we're going to go through the answers. We'll start with question 1. So we're going to substitute in the information that we know. So we've got pi times 3 squared times 2, because we've got the circle on the top and the bottom. And we're going to add that to pi times the diameter, which will be 6, because of course it's double the radius, times by the length of 10. So if you pop all of that information into your calculator, so pi times 3 squared times 2 times 60, that leaves us to 1 decimal place with 245.0 centimeters squared. Question 2, so you're asked to round your answer to 2 decimal places. Again, we're going to substitute in what we know. So we've got pi times the radius, which is half the diameter. So it's pi times 7 squared times 2, because of our circle on the top and the bottom. Then we've got pi times the diameter, which is 14, multiplied by the length, which is 16. So that is what we should have been popping into our calculators. So pi times 7 squared times 2 plus pi times 14 times 16, which gave us a surface area of 1011.6 centimeters squared. Question 3, so we've got to try and find the height. So we're going to substitute in all of the information that we know, set up our equation, and then rearrange to find h. So we've got pi times 11 squared times 2 plus pi times the diameter, which of course is double the radius, so it's pi times 22, and then times by the length of our cylinder, which in this question is known as the height, and we're told that's all equal to 850. So we want to try and isolate the h, get the h all on its own on the left-hand side of the equals. So we're going to take this entire first bracket and subtract that from both sides. So we're going to say minus pi times 11 squared times 2, and we're doing that to both sides. So on the left-hand side of our equals now, we're left with pi times 22 times the height is equal to 850, all divided by pi times 11 squared times 2. Now, to get the h on its own, we need to get rid of the pi and the 22. So we're going to divide both sides by pi times 22. So that's going to leave us with h equals 850, and that should have been minus pi times 11 squared times 2, all divided by pi times 22. So apologies for this bit. That should have been a minus. Squared times 2. So we're subtracting the bracket first and then dividing afterwards. So now we can type all of that into our calculator. So 850 take away pi times 11 squared times 2 all over pi times 22, which gives us a value of h as 1.3 centimeters. Question 4. So this time we've got to try and find the radius. Again, we're just going to substitute in what we know. So we've got pi times the radius squared times 2 plus pi times 2r, because remember 2r is another way of expressing the diameter, multiplied by the height of 6, and we're told that is all equal to 1040 pi. So we're going to simplify down each bracket. So we're going to rewrite this bracket here as 2 pi r squared. The second bracket we're going to rewrite as 12, because we can multiply together the 2 and the 6, pi r, and that's still all equal to 1040 pi. Now each number is a factor of 2, so we're going to divide through by 2 pi, because each term also has a pi in it. So we're going to divide every single term by 2 pi, which is going to leave us with r squared plus 6r equals 520. So now what we're going to do is we're going to substitute in values for r until we get a value that equals r 520. So I'm going to start with r equals, what should we reckon? R equals 20. I reckon would be a good starting point. So if we say that if r equals 20, what's that going to give us? So does r equal 20? Let's see. If we do 20 squared plus 6 times 20, what does that give us? 20 squared is 400. 6 times 20 is 120. If we add those together, got it first time, there we go. 520. So we know that r equals 20 centimeters. Yes, it does. Challenge 1. So they've got the same surface area, so we're going to work out the surface area of our cylinder and then use that to work out x on our cube. So the surface area of our cylinder, we're going to have pi times 5.5 squared times 2 plus pi times 11 multiplied by the length of 4. So we type all of that into our calculator. Times 11 times 4. That will give us a surface area of 328.3 centimeters squared. So that's what we know the surface area of our cube is. So 328.3 centimeters squared. We can express the area of one face of our cube, because that's going to be x times x, which we can also express as x squared. We know we've got 6 faces on our cube, so the total surface area will be 6 times x squared, which is 6x squared. So we can say that, what if 6x squared is equal to 328.3 centimeters squared, which is what we're told is the total surface area of our cube. We can rearrange our equation to work out what x is. So we're going to divide both sides by 6 first. So we're left with x squared equals, so 328.3 divided by 6. That leaves us with 54.7. And then we can square root both sides to get rid of the square. So we're left with x equals 7.4 to 1 decimal place centimeters. Okay, challenge 2. So we've got this cylinder with a hole in the middle, and then it's then been cut in half as well. So we're going to try and find the total surface area of this shape. Now we're going to start by finding the surface area of this section here, which is sort of the cross section of our shape. Now to find the surface area of this section, we're going to have to find the area of what the smaller circle was, the area of this bigger circle, what that was, and then take the smaller one away from the bigger one. And that will tell us then what was left over in the middle. And we're going to do that assuming we had full circles, and then we're going to halve it in the end to just work out what half of this bit left over is. So we're going to start with the big circle. So we were told it's got a diameter of 20. So we're going to start by saying pi times 10 squared. So that's the area of our big circle. And we're going to take away the area of the smaller circle, which is pi times, which has a diameter of 12, say 6 squared, which leaves us with an area of 201.1 centimeters squared. So if this was still a full cylinder that hadn't been cut in half, that'd be the area of this bit all of the way around, this middle section here. But we've only got half, so we're going to do 201.1 divided by 2, which leaves us with 100.55 centimeters squared. However, on the opposite side, we've got exactly the same U shape on the other side. So we now need to times this back by 2 again. So 100.55 times 2 leaves us back with our 201.1 centimeters squared. Now we're going to try and find the surface area of the big curved surface, so the bit on the outside, so the bit that you can just see here, which obviously then continues all the way under our cylinder. So the curved surface we know is pi times the big diameter, so 20, times by the length, which is 50, and then we're going to divide it by 2 because it's been cut in half, so we've only got half of that curved surface. That leaves us with 1,570.8 centimeters squared. So that's our big curved surface. Then we're going to work out this smaller curved surface on the inside, so this bit here. So similar to what we've just done, pi times the diameter, which is 12 this time, times by the length, which is 50. And again, we've only got half of this curved surface, so we're going to divide it by 2 again. That leaves us with 942.5 centimeters squared. The last bits we need to find the surface area of are these rectangles on the top. So we can see it's got a length of 50, but we need to try and work out the width. We're told the width of our entire shape is 20, and this middle bit is 12. So the width of 2 of these rectangles is 8. So we're going to halve it to work out what just 1 is. So 1 width is just 8 centimeters, 4 centimeters, sorry. And this is also 4 centimeters. So now we're just essentially finding the area of a rectangle. We've got 50 times 4, which is 200 centimeters squared. And of course, we've got 2 of those. We've got this one here, and we've got this one here. So we're going to times that by 2 to give us 400 centimeters squared. Now we're going to add up all of our areas. So we're going to do 201.1 plus 1570.8 plus 942.5 plus 400, which adds up to 3,114.4 centimeters squared.